Hello, here is a video on the dot product and finding work using vectors. So suppose a shopping cart is being pushed by a customer with a force of 15 pounds. I'm going to go ahead and underline important pieces of information. Force of 15 pounds at a downward angle of 52 degrees from the horizontal as shown in the diagram. If the cart was pushed 15 feet up a ramp at an incline of 12 degrees, how much work is done to push the stroller? So it is at a downward angle of 52 degrees. So this 52 degrees is this angle right here. And the cart was pushed 15 feet up a ramp that has an incline of 12 degrees. So in order to find the work is going to be the dot product of your force vector and your displacement vector. So what I want to do is I want to be able to find both of these vectors. So we're going to start with the force vector first. So I'm going to label this as the force vector. So in order to figure out the force vector, what I need to do is I need to find my individual components of the force. So what's happening when I push a shopping cart is it's creating this force vector kind of going down and forward so I can push the cart forward. So when I am finding these components, I always need to find my angle from standard position. So this is my positive x-axis until I hit my vector. So to calculate this, I'm going to take 360 minus 52, and that gives me 308 degrees. So that's the angle measurement that I'm going to use to calculate the components of the force. So the force has a magnitude of 15 pounds. So to change this to a vector, I'm going to take 15 cosine of my angle from standard position, which was 308 degrees. And 15 sine of my angle from standard position, and that's going to give me my two components for the force. So I'm going to go ahead and calculate that. Double check to make sure your calculator is in degree mode. That way it is giving you the correct values. So my force vector has a horizontal component of 92.3 and a vertical component, actually that's wrong, I typed it into my calculator wrong. I used 150 instead of 15. Let's try that again. Let's see. Okay, so 15 cosine of 308 is 9.23. 15 sine of 308 is negative 11.82. And if you look at the quadrant that this vector is in, it is in the fourth quadrant where your x's are positive and y's are negative, which means we would have a positive horizontal component and a negative vertical component. Okay, so let's talk about displacement. So displacement is how our cart is moving or where it's moving towards. So it is actually going up a ramp at an incline of 12 degrees. So when I am moving, I am not just moving forward, but I'm also moving up since I have an incline. So when I want to find my displacement vector, which I'm going to label as DISP, I need to find my horizontal and vertical components of the displacement. I am moving 15 feet. So that would be my magnitude of my displacement vector, but I do have an angle, so I need to find my individual components using cosine and sine. So I have 15 cosine, is it 15 feet? 15 pounds and 15 feet. Okay, so 15 cosine of 12 degrees, 15 sine of 12 degrees, and that is going to give me my individual components of the displacement vector. So I have 15 cosine of 12 is 14.67. 15 sine of 12 is 3.12. Okay, So now if I want to find the work done, I need to take the dot product of these two vectors. Well, what is the dot product? The dot product comes from taking your horizontal components, which is 9.23, and multiplying them together. So 9.23 times 14.67. I'm also going to take my vertical components, multiply them. So negative 11.82 times 3.12, and I'm going to add those two numbers together. And that is calculating the work using the dot product. So I have 9.23 times 14.67 plus negative 11.82 times 3.12. And that gives me 98.53. And my units for this are foot-pounds, since I'm moving in the units of feet, and my force is in the unit of pounds. So it is foot-pounds. And this right here is your final answer. All right, so just to recap, when you're calculating work using vectors, it is a dot product of your force vector and your displacement vector. So you want to find those vectors first. When you're finding your components, make sure you're using the angles from standard position. Use magnitude times cosine of your angle for your horizontal component, magnitude times sine of your angle for your vertical components. Displacement vector, same thing, but using your distance that you're traveling, as well as the incline if there is an incline. Work is the dot product of those two vectors. So I can multiply my horizontal components together, multiply my vertical components together, and add those two numbers together. All right, so that concludes our quick little video on calculating work using vectors.